Although we can still interpret those one-sided limits, you already know from your study of algebra and trigonometry at some previous course that the graph of f of x equals 1 over x has a vertical asymptote. We can use that limit that we just determined as a way of describing what is happening at this vertical asymptote. On the left, we go downward. On the right, we go upward. And so the one-sided limits describe the behavior around the vertical asymptote. Right? The limit does not exist. The one-sided limits don't exist, but they don't exist because they become infinite. On the left, it becomes negative infinity. On the right, it becomes positive infinity. And that pair of behaviors, whenever the one-sided limits are both infinity or both negative infinity or one and the other, like we have here, that will always describe a vertical asymptote. That's true when you're dealing with rationals. That's true when you're dealing with more complicated things that try to pretend they're rationals but aren't really. So for example, let's consider the function g of x equals x over the square root of x squared minus 1. All right, well, I know that this is going to have some discontinuities to it. Right? The square root of x squared minus 1 is in the denominator. And so whenever that is 0, we're going to have a problem. And it's a square root. So whenever the stuff inside is negative, we're going to have a problem. This is algebra trigonometry level analysis. We need to be able to analyze quickly that this is undefined when x squared minus 1 is less than or equal to 0. It will only be defined when x squared minus 1 is greater than 0. Right. So we know that weird things are going to happen on this interval between -1 and 1. The function will not be defined. It will only be defined outside. We could try to continue graphing by hand here. And as we progress in the course, we're going to develop some tools to make it easier to try to graph this thing by hand. But for today, let's just jump over to Desmos and let it do the heavy lifting for us. We can see, based on this graph, there are some horizontal asymptotes and some vertical asymptotes. For right now, I just want to focus on the vertical asymptotes. It looks like, although I'm not 100% certain, it looks like there should be a vertical asymptote at x equals 1 and at x equals -1. Let's change the settings on this graph and make those dotted lines. There we go. And the space in between, oops, sorry about that. the space in between, the function just isn't there. And that's to be expected. One of the things that comes out of this, I can't take the overall limit near this asymptote to see what's happening, because the limit from the right, there's nothing. There's nothing here to take a limit of. I can only take the one-sided limit from the left, and on the other curve, I can only take the one-sided limit from the right. With that in mind, let's go ahead and do that. Back to my note page. Let's take the limit as x approaches -1 from the left of g of x. Extra stray mark in there. Let's get rid of that. -1 from the left. Right? Well, again, whenever x is smaller than -1, x squared is bigger than 1, so x squared minus 1 is bigger than 0, which means that we can take this limit inside. We can have the limit as x approaches -1 of x in the numerator, and in the denominator we can have the square root of the limit as x approaches -1 of x squared minus 1. And when we take that limit, we are going to get -1 over the square root of 0, which is undefined, which tells us that this limit does not exist. Then from there, we can do a numerical analysis, which we kind of just did because we had the computer draw the graph. And we can more specifically say that the limit as x approaches -1 from the left of g of x is going to be -infinity. Again, you can put in numbers and do the analysis by hand if you want, right? -1.1, negative 0.9, negative 0.99, negative 0.999, etc., 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 gets you closer and closer. But the computer did it for us. We don't have to go and do it again. Right. You can do the same sort of thing with the limit as x approaches +1 from the right, which is the other place where interesting things happen in this particular function. So with all of those ideas in mind, I would like you to play around with this limit. The limit as x approaches 1 of x plus 2 over x minus 1, the whole thing squared. All right, take a couple of minutes to play around with that, see what you end up with on that one, and I'll see you in the next video.